Yes, I am audible. आपकी वॉइस में प्रॉब्लम आ रही है.
गुड इवनिंग सर.
Yes, good evening. Yes, now okay. Fine.
ना ओके ना, मतलब यहाँ पे बारिश हो रहा है ना, इसलिए नेटवर्क थोड़ा गड़बड़ हो रहा है, इसलिए करंट भी जा सकता है कभी भी. हाँ सर, ठीक है. इज
Yes,
इट ओके
today.
सर?
Yes, fine. Today कौन सा टॉपिक करके आए हैं आप?
सर कोऑर्डिनेशन केमिस्ट्री, आई थिंक थर्मोडायनेमिक्स लास्ट, मतलब इतना तो, और बाकी आपने उस दिन पूछ ही लिया था सब कुछ अराउंड, तो उसके बाद मैंने कोऑर्डिनेशन किया है आज.
Today थर्मोडायनेमिक वो कोऑर्डिनेशन बेसिक.
हाँ सर, थर्मोडायनेमिक्स का तो ऑलमोस्ट हो गया था, फिर भी सर आप पूछ लीजिए. हाँ सर.
Yes, कोऑर्डिनेशन का आज स्टार्ट करेंगे. कोऑर्डिनेशन ना.
यस सर.
यस, स्टार्ट कीजिए कोऑर्डिनेशन बेसिक से पूरा टॉपिक कोऑर्डिनेशन, और उसको डिस्क्राइब कीजिए वन बाय.
Okay, sir. Sir, coordination chemistry is that type of branch of chemistry where we discuss about the coordinated compound. That means the compound which formed by metal which is surrounded by neutral ligand, or positively charged molecule, neutral molecule or positively charged molecule through coordinate covalent bond. That's how coordination compound are formed. In basically uses of coordination chemistry, we can use coordinated compound in industrial purpose. Basically, for the extraction of metal, we use nickel. For hardness and calculation of hardness of water, we can use EDTA. For lead poisoning, we can use EDTA also. And for what was it? For our living system, hemoglobin, chlorophyll, myoglobin, all are coordination compound also. And in medicinal, we have used the basic example is cisplatin used for cancer therapy. That is also the use of coordination compound. Yes, sir. We basically study about coordination.
Yes, coordination chemistry or coordination compound, what the difference?
Sir, coordination compound are only that means coordination compound means only the formation. That means the molecule which form, and coordination chemistry is the study of all the chemistry. That means color, that means application. Everything is related to coordination chemistry. Yes.
Yes, any example explain कीजिए. Any example of coordination compound? Describe one by one.
Yes, sir. Okay, sir. So example, we can take example of CO NH36Cl3. Okay, so here is the example of CO NH36Cl3. Here cobalt is the central atom. Oh yes, one thing I forgot that I have to add. Coordination compound is basically formed by only transition metal. Yes.
Yes.
Central metal, and this ammonia bond binding to cobalt atom through coordinate covalent bond, and this ammonia is basically called ligand, and this chlorine is the outside atom. Okay, and this compound is basically called, that compound is called what we call it as coordination compound. Okay, this compound is basically called coordination compound. Here the cobalt atom and ammonia molecule, both lost their identity. Both has lost their identity in coordination compound. That means it has no individual identity. It is only the molecule. That means cobalt and ammonia form one coordination compound. It lost their identity. Yes.
Yes, good. Yes, next, move on. Werner theory. Explain, describe.
Yes, yes, sir. Okay, so Werner theory is first theory for the use of that means coordination compound. Werner tell about that metal has two type of valency. One is primary valency and one is secondary valency. Primary valency is basically the oxidation state of metal and is neutralized by the anionic molecule anion, and secondary valency is that the secondary valency is basically the coordination number of the central metal, and it is basically neutralized or balanced by the neutral ligand or positively charged ligand. Okay, that is the main theory of coordination, Werner theory, main postulate. Yes, sir.
Yes, explain or be Werner theory, primary valency, secondary valency, what the difference? Explain one by one.
Yes.
Topic लिखिए Werner
Yes.
theory, describe कीजिए पूरा.
Okay, sir. So in cobalt, here I am taking cobalt ammonia. So here cobalt, now the coordination number of cobalt is 6. Okay, so coordination number is 6. That means cobalt has secondary valency. Cobalt has secondary valency of 6, whereas the surrounding atom, that means this ion charge is balanced by the 3 chloride atom. This is called the primary valency. Okay, there are 3 chloride atom. So the primary valency of cobalt is +3. So primary valency is basically the oxidation state of metal, and secondary valency is the basically coordination number of the metal. Okay, so that is the main difference between primary and secondary valency. Suppose I am taking another example, Cn6 4-. Okay, so here chromium has oxidation number of +2, so that is the primary valency. Okay, and chromium has coordination number of 6, that is the secondary valency. Yes, sir.
Yes, good. Any drawback limitation of Werner theory?
Sir, Werner theory only tells about the formation of coordination compound, but it cannot tell about the paramagnetic character, diamagnetic character, how coordination compound is formed. It only predict that coordination compound is where metal has two type of valency. It only predict this type of things, these two things only, but it cannot predict the magnetic character of molecule. That means some coordination compound are attracted by magnetic field, and some coordinated complex are that means repelled by magnetic field. This type of things coordination Werner theory cannot explain. Yes, sir.
Yes. Next, move on ligands. What is ligands?
Yes, sir. Ligand are those type of molecule which has lone pair of electron, or that means which has lone pair of electron, and which donate its lone pair of electron to metal atom through coordinate covalent bond. Suppose I am taking one example, ammonia. Okay, so I am taking one example of ammonia. Here ammonia has lone pair, one lone pair. Okay, ammonia has one lone pair, so ammonia can donate its lone pair to metal atom. Okay, so that's why ammonia can act as a ligand. Okay, ammonia can act as a ligand. And suppose I am taking another example of water. So here you can see that water has two lone pair of electron. So water can donate its lone pair to metal. So that's why water can also act as a ligand. And again, I am taking Cl minus. Cl minus has 4 lone pair of electron. So Cl minus can act as also a ligand. So ligand can be of negatively charged, ligand can be of positively charged, or ligand can be neutral also. Yes, sir.
Yes. What the difference between a positive, negative, and neutral ligands? Explain.
Yes, sir. Positive ligand, suppose I am taking one example of positive ligand is nitrosyl, NO positive. that is a positive ligand example. And suppose I am taking Cn minus, that is a negative ligand example, or SCn minus, or halide, all halide, Cl minus, Br minus, iodide, and I am taking example of ammonia, water, that was, yes, ammonia, water. These are, or carbonyl, all are neutral ligand. So positive ligand are those type of ligand which has positive charge in its cell, or negative ligand are those type of ligand which has negative charge on their, yes, negative charge in it, and neutral ligand are those which has no any charge, but all the ligand should have lone pair of electron on it. That is the main criteria for a ligand.
Yes. What is the ambidental ligand?
Yes, sir. Ambidental ligand are those type of ligand which can donate each lone pair of electron through which can has two donor side, but it can donate through only one donor side at once. Suppose I am taking SCn minus. Suppose I am taking SCn minus here. Sulfur also has lone pair of electron, and nitrogen also has lone pair of electron. So it can donate through sulfur also, and it can donate through nitrogen also. So that's why it is thiocyanide. Thiocyanide is a ambidental ligand. Again, I am taking another example of Cn minus. Cn minus is also, it can donate through carbon, it can donate through nitrogen. That means those type of ligand which can donate, which can has two donor side, but only it can donate through only once at a time. That is called ambidental ligand. NO2 negative is also a one type of ambidental ligand.
Hexadental ligand. What the example of hexadental?
Yes, sir. Hexadental ligand, that means hexadental ligand is basically a polydental ligand which has 6 donor side. One example, that is the famous example of hexadental ligand, is EDTA4 minus. EDTA4 minus and ethylene diamine tetraacetate. It is this one. Yes, that is the example of hexadental ligand. That means it can donate through nitrogen, 2 nitrogen atom. It can donating through 4 oxygen atom. So it has 2 donor nitrogen and 4 donor oxygen atom.
Yes. What is bridging ligand?
Yes, sir. Bridging ligand are those type of ligand which can bridge 2 metal atom. Okay. Suppose I am taking one example of, that is bridging ligand which has 2 lone pair, or which can more than 1 lone pair of electron. Suppose carbonyl group. Yes, carbonyl can donate carbonyl can bridge 2 metal atom. Okay, carbonyl can bridge 2 metal atom, or it can bridge 3 metal atom also. And suppose I am taking another example of OH minus ligand that can bridge 2 metal atom also. OH minus is also a bridging ligand, or Cl minus can also be act as a bridging ligand. But ammonia cannot act as a bridging ligand. But NH2 minus can act as a bridging ligand.
Yes, good. Flagedental ligand. What the example of flagedental ligand?
Yes, sir. Flexidental ligand are those ligand which has 2 donor side, or it can increase its density. That means it can donate at through 1 atom, it can donate through 2 atom, or that means it can increase its donor side at a, मतलब जब मतलब उसको importance होता है तो वो donate, मतलब it increases density. That type of ligand is called flexidental. That means those type of ligand which can sense their density is called flaxidental ligand. Is it okay, sir? Flaxidental ligand, one example is EDTA4 minus, EDTA4 minus, or
CO3 2 negative, SO3 2 negative, SO4 2 negative, NO3 negative.
yes, sir. All are. Sir, definition तो ठीक था ना?
Yes, right. Symmetrical and unsymmetrical wide-ended ligand. For the example.
सर क्या बोला आपने?
Symmetrical and unsymmetrical wide-ended ligand.
Okay, sir. So symmetrical and unsymmetrical. Okay, so symmetrical ligand are those symmetrical bidentate only. I am taking example of ethylene diamide. Okay, so ethylene diamide it can donate. So it is bidentate ligand and it has both the donor side are same. That's why it is called symmetrical bidentate ligand. And I am taking another example, that means glycineto complex. Glycineto ligand. That means NH2, CH2, C double bond O minus. I don't know that is the exact structure, but same thing. It can donate through nitrogen, it can donate through oxygen. That means it is unsymmetrically bidentate, but which has two donor sides are different. That is called unsymmetrical bidentate ligand, and those which has two donor sides are same, that is called symmetrical bidentate ligand. Yes, sir.
Yes, good. Example of symmetrical and unsymmetrical.
Sir, example is ethylene diamine is an example of symmetrical bidentate ligand, and glycinate so is an example of unsymmetrical bidentate ligand.
Yes. Next is macrocyclic ligand. What is macrocyclic ligand?
Macrocyclic ligand, that means the large, that means bulkier ligand are called macrocyclic ligand, and those are porphyrin ligand or corrin ring, porphyrin ring, corrin ring, porphyrin ring. That means which which are in hemoglobin, myoglobin, chlorophyll. These are called macrocyclic ligand. Is it okay, sir?
Yes. Any drawback limitation of a ligand?
Sir. Don't know, sir. Drawback and limitation ligand का क्या होगा? Ligand, no idea, sir. No, sir.
लगाइए थोड़ा दिमाग, क्या हो सकता है लिगेंड्स के, क्या ड्रॉबैक हो सकते हैं, लिगेंड कहाँ यूज नहीं होता.
Ligand का use we cannot use. That means in for normal molecule, ligand only donate through coordinate covalent bond. That is the main difference. And but in normal molecule, those type of things which donate. That means ligand cannot that means lose it electron or gain the electron. For simple molecule formation ligand, we cannot use the ligand. Suppose we form for ammonia, we can form coordinate complex. But for double salt or simple salt NaCl, we cannot make NaNH3. We cannot make NaNH3. Something like that. Don't exactly, sir. याद नहीं आ रहा, आप एक बार बताइए तो.
लगाओ बताओ, कुछ आइडिया लगाओ थोड़ा और.
ligand कुछ तो specifically which is ligand को याद है. सर लिमिटेशन बहुत ही इजी होगा, लेकिन याद नहीं आ रहा है मुझे. केमिकल No, sir.
Because ligands does not winding. Yes. वाइंडिंग कर सकते ना उनको अलग तरह से.
Okay. But that means it cannot bind through ionic bond or.
यस, दो के साथ नहीं हो सकता, एक के साथ बॉन्ड कर सकते हैं, जैसे आपने अभी बाइडेंटेड लिगेंड के एग्जांपल बताए थे, ठीक है ना, किस तरह से बाइंड किया जा सकता है. और इट्स कांट बी एक्सप्लेन द सर्टेन लिगेंड्स. एक साथ एक ही होगा, अदर मिक्स नहीं कर सकते इनको. कॉम्प्लेक्स में आप कितने लिगेंड्स लगा सकते हैं, कितने लग सकते हैं कोई कॉम्प्लेक्स बनाते हैं आप?
Around sir 12, almost 12, maximum 12 एक कॉम्प्लेक्स में.
तो उनमें क्या है, कॉम्प्लेक्स हर एक डिफरेंट डिफरेंट टाइप्स के लिगेंड्स लग सकते हैं कि अदर ओनली वन टाइप?
डिफरेंट डिफरेंट है, डिफरेंट भी लग सकता है और सेम टाइप ऑफ लग सकता है वहां पे. मतलब
सेम की पॉसिबिलिटी ज्यादा, डिफरेंट की पॉसिबिलिटी कम है. तो इसीलिए ये एक्सप्लेन करना होता है. लिगेंड्स कैन नॉट बी एक्सप्लेन द एनी कॉम्प्लेक्स इन एड इन डिफरेंट लिगेंड्स.
ओके.
वाइंडिंग नहीं कर सकता, डज नॉट वाइंड.
डज नॉट बाइंड.
यस, 2 पॉइंट हो गए लिगेंड्स.
ओके सर.
तो ये हो गया हमारा बेसिक ऑफ कोऑर्डिनेशन कॉम्प्लेक्स. नेक्स्ट मूव करते हैं हम इसी में ही. नेक्स्ट टॉपिक इज आइसोमेरिज.
ओके सर.
यस, व्हाट इज आइसोमेरिज and what the difference between inorganic and organic isomerism? Explain one by one.
Okay sir, isomerism is those type of matlab those molecule which have same molecular formula but the structure and orientation, basically the structure and orientation is different. That is called basically isomerism. Okay. So in inorganic isomerism we can get the ionization isomerism, we can get the ligand isomerism, but in coordination isomerism we cannot ionize the molecule. That's why we cannot get ionization isomerism or like that is called ligand isomerism. We cannot get that. But in inorganic similarly in similarity is that we get DL configuration, DL isomer in inorganic also. We can get DL isomerism in organic also. Yes sir. That means inorganic isomer and optical isomer, those are optically, we can get optically active isomer, but like that means like what, like ionization isomerism, we cannot get the we cannot ionize the organic molecule. That's why we cannot get ionization isomerism. We cannot get positional isomerism in inorganic molecule also. Is it okay sir? और क्या था? और तो नहीं सर.
ये टाइप्स, आइसोमेरिक टाइप्स जो आपने बताए, एक्सप्लेन, इनको एक्सप्लेन कीजिए वन बाय वन, बोर्ड पे कीजिए, बोर्ड.
Okay. So that means one is ionization isomerism. That means they are for structural isomerism. They are okay. Structural is ionization isomerism. In ionization isomerism, the ionized substance is different. Suppose I am taking CO NH3 Br SO4. Okay. If we put this complex in water aqueous medium, then sulfate will precipitate. That means we can get white precipitate with the help of barium chloride. But similarly, the same thing, CO NH3 SO4Br. Here if we ionize this molecule, then the ionization substance will be bromide. That means we ionize this complex or we can get this precipitate as silver nitrate. So silver bromide. Okay, brown precipitate we will get. and ligand isomerism. Ligand isomerism is there. That means which has ligand isomerism is shown by those type of complex which has ambidexter ligand. Ambidexter ligand is suppose CO CN CO NO2 NO2 6. Here all the here cobalt is binded ligated through nitrogen atom. Okay, since NO2 is a ambidexter ligand, so it cobalt can bind through oxygen like this atom also. So this is an example of ligand isomerism. ठीक है सर? So ligand ionization और क्या था? One is, that means one is sol, ये तो solvated भी हो गया, ऐसा मैं तो भूल ही गया. थ्री सार ये था, थ्री तो एक कॉम्प्लेक्स आइसोमरिज्म था, ये मतलब ऐसा था.
Yes, ionization, hydrate, linkage, coordination, position, ligand, polymerization, isomerism. Yes, now 7 types of structural isomerism.
मतलब इसके बाद हाइड्रेटेड आएगा, वाटर के साथ जो होता है, एंड देन सर व्हाट वाज इट, वन इज देयर, दैट मींस one is that means complex isomerism is there and hydrated. हाँ सर, ये I have to think, that means isomerism तो याद ही था, ऐसे मतलब नहीं पढ़ा था, तो ये देखना होगा मुझे थोड़ा, ऐसा हो जाएगा ये.
कोई प्रॉब्लम नहीं, इनको देख लेना आप, इनके टाइप्स आप
हाँ
देख,
सर,
इनके टाइप्स आप एक बार देख लेना, उससे आइडिया लग जाएगा आपको. जैसे स्टीरियो आइसोमेरिक टाइप्स, ज्योमेट्रिकल, ऑप्टिकल, उसको एक्सप्लेन कीजिए.
Yes, sir. Geometrical isomerism is stereo is geometrical isomerism. Geometrical isomerism, it is that is cis-trans form, or it can have one form is facial and meridional form is also. Suppose I am taking example of CONH34 Cl. The compound is octahedral in shape. Okay, the compound is octahedral in shape structure. So the chlorine chlorine atom, chlorine ligand can bind is like that also in octahedral shape, or chlorine can ligate through chlorine ammonia, and there is ammonia, and there is ammonia. Okay, so here you can see in this the chlorine and chlorine bond angle is 90 degree, and here you can see chlorine bond angle is 180 degree. So that is here this if the ligand has bond angle of 90 degree, that is called cis isomerism, and if the ligand has bond angle of 180 degree, that is called trans isomerism. And suppose I am taking another example where the ligand is only cis-trans isomerism, geometrical isomerism is not shown by tetrahedral complex. Okay, only cis-trans isomerism is shown in octahedral complex and square planar complex. Suppose I am taking another example, that is P platinum NH32Cl2. Okay, this is a square planar complex. So ammonia can ligate through in the same side. Ammonia can take the position of same side, or ammonia can take the position of different side. Okay, so here the chlorine on ammonia bond angle is 180 degree and 90 degree, so that is called cis, and this is called trans. Okay, this type of isomerism is cis-trans isomerism. Cis-trans isomerism are shown by only square planar and octahedral complex. Basically form of Ma4B2 or Ma2B2. And for facial and meridional, I am taking example of form Ma3B3 type. So here, if the ligand are in the same phase that is called facial isomerism. And if the ligand are in a different phase, it form by connecting the three ligand in different phase, then it is called meridional isomer. Suppose I am taking this M3B3 from all the AAR. I am taking this example. This A, okay. These are in same phase, so that's why it is called facial isomerism. Okay, and if I take one A is there, one A is there, and one A is there. Okay, this is not in the same phase, so that's why it is called meridional isomerism. Yes, that is the main difference between facial and meridional. Okay, sir. Is it okay, sir?
Yes.
Okay. From going to optical isomerism is basically since square planar complex has plane of symmetry, so it cannot show optical isomerism. Only octahedral complex basically show what is called optical isomerism. Optical isomerism. Suppose optical isomerism, those type of isomerism, when the mirror image are not superimposable by each other. That is the main criteria to be optically active isomer. The mirror image are not superimposable to each other, and they are called enantiomer also. We can take example. We can give them name as D and L. Suppose I am taking cis CONH3 Cl cis form. Okay, so here CO chlorine, ammonia. Okay, so this is if I put mirror here, so the chlorine will come like this in front of the mirror, and ammonia will go behind the mirror. So this will form like that. Okay, and if I copy, suppose I am taking, if I copy this molecule to this, these two isomers are not superimposable to each other. Okay, so that's why it is called non-superimposable mirror image, and they are optically active. And if I take the trans isomer, okay, if I take the trans isomer, suppose I am taking trans isomer of this, then chlorine will come to 180 degree of each other, so it will form. See, you are getting the same thing. Okay, so here if I put this to there, then these two isomer, that means these two molecular superimposable, that means these two mirror images are superimposable to each other, so that's why it is not optically active. That means we can tell that cis isomer of CONH3 is optically active, whereas trans isomer of CONH3 is optically inactive. Yes, sir. Up to this is okay, I think.
Yes, good. But the difference between optically active and inactive compound? What the example?
Optically active, yes. Optically active compound are those compounds which rotate the plane polarized light, and optically inactive compound are those compounds which cannot rotate the plane polarized light, basically. Okay, so if the plane polarized light rotates by to right side, then it is called dextrorotatory, and if the plane polarized light rotates to left side, then it is called levorotatory. Okay, so that is the main difference. And optically active compound, from structure we can say that if the mirror images are not superimposable to each other, then it is called optically active compound. And if the mirror images are superimposable to each other, then it is called optically inactive compound. Yes. Suppose I am taking my letter alphabet, that means U here. That means if I put mirror here, then this will happen. That means this and these are superimposed. That means this is optically inactive. Okay, that means superimposed. Okay. Simple thing. Okay, sir.
What the difference between meso compound and racemic mixture? Anyone example?
Okay, sir. Meso compound are those compound which has, that means from organic I can give example. Meso compound are those compound which has plane of symmetry, that are called meso compound, which has plane of symmetry. Suppose I am taking this molecule HOH and CH3, that means butane 1,2-diol or butane 2,3-diol. Here it has plane of symmetry is there. So these two sides are equal. That means it is a meso compound. Okay. And racemic compound are those compound. Racemic mixture are those mixture which are optically active, but the percentage of both are same. That's why it is called racemic mixture. Percentage, that means percentage of D and percentage of L mixture both are same. Then it is called racemic mixture. In SN1 reaction, SN1 reaction we get racemic mixture, but in SN2 reaction we can get the optically active mixture. That means we can get only one product from where yes, that will be the main example, I think. Is it okay, sir?
Yes.
सर मैं एक बात बोलता हूँ आपको, मतलब जब मैं मतलब डिस्कस करता हूँ, मतलब इलाबोरेट करता हूँ, तो मतलब मेरा आवाज ज्यादा हो जाता है ना?
कोई नहीं, वो ठीक है। वो तो मैं अब यहाँ पे आप बोल रहे हो, वहाँ पे लोग कई लोग बोले होंगे, 5 लोग 5-6 लोग हो गए इंटरव्यू पैनल
हाँ
में,
सर।
तो सबको सुनाई तो देना, इतनी तो तेज बोलना ही चाहिए ना। अब आप दूर, यहाँ तो पास में हो, वहाँ तो दूर हो गए आप बोर्ड पे, और वो लोग दूर
हाँ,
बैठे होंगे।
आवाज तो यही फ्रीक्वेंसी ठीक है ना, मतलब
हाँ, यही
कॉलेज में
सही
तो मतलब जैसे पढ़ाता हूँ ऐसे ही मतलब पढ़ाते थे। हाँ सर।
फ्रीक्वेंसी तेज होना चाहिए, जो सही रहता है। इतना तेज ना
हाँ
हो
सर।
समझ में ही ना आए, इतना तेज होना चाहिए कि ठीक है, सामने वाले को पता चले कि आप टॉपिक बोल रहे हैं, तो वो क्या।
मतलब ऐसा तो नहीं लग रहा है ना सर, ऐसा तो नहीं लग रहा है, मतलब मैं हाइपर होके बोल रहा हूँ, ऐसा तो नहीं लग
ना
रहा
ना ना ना।
है ना? ओके सर। मतलब जब मैं
हाँ,
पढ़ाता हूँ तो अलग एक जोन में ले जाता हूँ सर, इसलिए मतलब अलग जोन में चला जाता हूँ, इसलिए इसलिए थोड़ा दिक्कत है। हाँ
सिक्स ट्रांस और डीएल, इनमें क्या डिफरेंस है?
sir, cis trans is basically a geometrical isomerism where the only structure we can deal with only the, that means orientation of the molecule. Okay, that means if the angle between the ligand is 90 degrees, then it is called cis. If the angle between the molecule is trans, then it is 180, then it is called trans. And in optical, that means D and L configuration, we deal with the optical rotation of the plane polarized line. If it rotates through right direction, then it is called dextro or D rotation, or if it rotates through to left direction, then it is called levorotatory. Yes, sir. That is the main difference, I think.
यस।
सर जो मैंने आपको केमिस्ट्री मीम दिया था, वो मतलब बोल सकता हूँ ना वहां पे?
क्या चीज?
सर जो मैंने आपको मतलब केमिस्ट्री का जो जोक भेजा था, लिटिल लिटिल
हाँ।
व्हाट्सएप में,
यस।
वो तो बोल सकता हूँ ना?
क्वेश्चन तो आप बोल सकते, कोई प्रॉब्लम नहीं है, आप अपने हिसाब से बनाए ना, अपने अपने माइंड सेट से। बस ये है कि उसका
हाँ सर।
डायरेक्शन गलत नहीं होना चाहिए। जिस तरह से आप बोल रहे हैं उनका आप एग्जाम्पल दे दीजिए, कोई नहीं है, ई और सी कोई प्रॉब्लम नहीं है,
हाँ सर। अच्छा अच्छा अच्छा।
कोई
ओके।
दिक्कत नहीं आती। बस उसका व्यू प्रेजेंटेशन गलत नहीं होना चाहिए, बस समझ में आना चाहिए।
ओके सर, ठीक है।
ठीक है, ये आज इतना बेसिक हो गया पूरा। कल हम इसका
हाँ
नेक्स्ट
सर।
आईपीएससी नोमेनक्लेचर, मेटल लिगेंड थ्योरीज, कलर ट्रांजिशन,